Alright, welcome to lesson 2.1 of variables and patterns. So looking at an idea about renting some bicycles. Today we're going to look at how to compare a table to a graph. So we know how to make them both. Now we're going to look at the differences between them both. So we're going to analyze a table and graph and compare the results. So let's take a look. Comparing bike rental shops. Mike wants to rent bikes for his class to go on a bike ride. He gets prices from two competing bike rental stores. Rocky's bike shop gave Mike a table, and Adrian's bike shop gave Mike a graph. So if we take a look, we have Rocky's rental rates, and we have Adrian's rental rates. So let's look. First question, which bike shop do you think is the best deal and why? Well, it depends what we're looking for. Best deal obviously means the cheaper one, because if you're getting bikes, you're getting bikes. It doesn't really change things. So let's say I want 20 bikes. 20 bikes makes sense for a class. So Rocky's charges $770, and Adrian's 20 bikes costs $600. So $600 or $770. So obviously Adrian's, because 20 bikes cost less there. Makes sense. Cheaper bikes, better deal. B, how much does each company charge for 10 bikes? Circle which one is the better deal. 10 bikes. 10 bikes costs under $400, probably $300. 10 bikes, $535. So $300 or $535. Whoops, I got those backwards. $535. 300. Better deal. Adrian's. 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 Still the better deal. How many bikes can you get for $1,200 for each company? Circle which one is the better deal. So if we're looking at money, let's see. Rental fee, $1,200. We can get 50 there. Adrian's, $1,200. We can get 40 there. So, Adrian's we get 40, Rocky's we get 50. Adrian's we thought was the best deal. Adrian's is the best deal there. Rocky's is the best deal there. So which bike shop do you think is the best deal now and why? Well, as we can tell, the more bikes you want, Rocky's makes the better deal. If you want enough bikes, you go with Rocky's. If you want a little bit of bikes, you go with Adrian's. So, for a small number of bikes, you go with Adrian. For a large number, you go with Rocky's. So each one is the best deal, just depends on how many bikes you need. Alright, let's move on. Practice problems. The table below shows the fees charged at a campground in Estes Park. So you have the title, which is the campground costs, number of campsites all the way up through 8, campground fees. Now, we're going to make a coordinate graph of the data. First thing up is the title. So campground, fees, taken from the title of the table. Independent variable, dependent variable. We need to figure out which is which. Does the number of campsites change the fee, or does the fee change the number of campsites? Well, in this case, the more campsites you need, the more you spend. So number of campsites is the independent, campground fees is the dependent. Also, if you've noticed by now, the independent variable is always on the top of the graph. So number of campsites and fee goes on the side. Now, number of campsites starts at 0, and we have to go all the way to 8. So I'm just going to count by 1. 1, 2, 3, 4, 5, 6, 7, 8. Fees starts at 0. We need to go up to 120. Now, here's a hint. We might be able to go up by tens. However, if I take a look, each time we add a campsite, we add $15, which means the pattern is counting by 15. I'm going to count by the pattern that's in the table. 45, 60, 75, 90, 105, 120, 135, 150. This makes it easy to graph, because at 0 campsites we have 0. At 1 campsite we have $15. 2 campsites is $30. Now notice I'm just in the corners the entire way up. When you count by a good scale, you make it really easy to graph. Connect the dots, and there we go. There's our coordinate graph for this problem. Now let's answer some questions about it. What is the relationship between the number of campsites and the campground fees? So number of campsites is the independent variable. As the number of campsites went up, the fee went up or down. Well, the more campsites you need, the higher your fee. Now we want to know what is the cost for the following number of campsites: 10, 20, and 100. 10 is not included on here. It's included on here. So if I go up, I know that 10 costs 150. So I can put that down. However, where am I going to get 20 and 100 for? I could make my graph bigger and go out to 20. I don't want to. I can make my table bigger and go out to 20. I don't want to. I definitely don't want to make them bigger and go out to 100. So what we need to figure out is how much does one campsite cost? Well, one campsite costs $15. 2 costs $30. 1 times 15 is 15. 2 times 15 is 30. 3 times 15 is 45. 4 times 15 is 60. So I just need to multiply my number of campsites times $15. 20 times $15 equals $300. 100 times $15 equals $1,500. Multiplication got us there a lot quicker than if I wanted to make this table nice and big or the graph nice and big. Multiplication gets us there quicker if you can. Alright, let's look back at the start of this lesson, make sure we've covered it all. So we're talking about renting bicycles, we're comparing a table to a graph, we're going to analyze the table and graph. Here we had our table, our graph, answered some questions, determined that they're both the best deal depending on how many bikes you need. We had a practice problem, we had this table, we turned it into a graph, and then we answered some questions out of it. This is the end of lesson 2.1. Up next is lesson 2.2, still out of variables and patterns.